Welcome to the second lab of determining the concentration of the acetic acid. The purpose of this experiment is to determine the concentration of the acetic acid in the sample using quantitative titration. So, what is important to remember here is that we're going to use the pH meter, but last time we used an indicator to figure out the pH change to find the equivalence point, and so on and so forth. So the concept behind this lab is titration, obviously. Titration is a procedure that is used to determine the concentration of a solution by reacting a known volume of that solution with a measured volume of a solution that has a known concentration. So in this lab, the acid is going to be the unknown concentration, and the known concentration is going to be the base, which is going to be potassium hydroxide. And how are we going to figure out the concentration is by looking for the equivalence point. So what is the equivalence point? Equivalent point is the point at which the amount of titrant is just enough to react with all the reactant in the sample. And the titrant is the solution with the known concentration, and which is going to be the base. So to figure out the concentration, what we need to find out is the exact volume that's going to neutralize the acid in the beaker, and LogoPro is going to help us with that. This is a list of material that is needed to complete the lab. We need a retort stand, two 150 ml beakers or 250 beakers, a funnel, a burette, potassium hydroxide solution with a concentration of 1, two burette clamps, one to hold the burette and one to hold the pH meter, a pH meter, LogoPro, and the acetic acid. First, fill the burette with potassium hydroxide until it reaches 0 ml, which is at the top, and use the funnel, otherwise you're going to spill potassium hydroxide everywhere. Then, use a graduated cylinder to pour 10 ml of acid solution into 150 ml or 150 ml beaker. After, set up the lab as shown in the picture, and the pH of the storing solution should be between 2 to 3. And now the pH meter should be already connected to the LogoPro. And next you go to experiment, and you should be able to see data collection on the drop down list. Click on it. This will pop up. Next, click on the drop down list right next to mode. Then click on event with entry, and this will pop up, and then fill it in.
Let's begin. Here we have our burette with potassium hydroxide right up to there, which is 0 ml. And here we have the beaker with acetic acid, and down there that's the pH meter. Before adding any potassium hydroxide, we must record a point for 0 ml added, and then we just need to add potassium hydroxide just enough to increase the pH by 0.15. And close the burette. And then press collect, and remember to wait until the pH is stabilized to press keep. And keep on doing this until you have a curve like that. And some things to remember. At this point, the pH will increase very slowly, but however, it will start to increase when you're close to the equivalence point, and then add potassium hydroxide until there is no change in pH. And also remember to do this procedure twice.
Of course, in the real world, you can't really get a beautiful curve like in the animation. So this is the curve that I got from my lab. In this case, the equivalent point is 10.6, which basically means it will take 10.6 ml of potassium hydroxide to neutralize the acid in the beaker. This is the neutralization reaction that happened in the experiment. Since the equation is already balanced, the ratio is going to be 1 to 1 to 1 to 1. Let's fill in the chart with the information that we know. We know the concentration of potassium hydroxide, which is 1 m, and we also know the volume of potassium hydroxide, which is 0.0106 liters, which we found from the experiment. And also we know the volume of acetic acid, which is 0.01 liters. Also, I convert all the milliliter volumes into liters. In order to find the moles of potassium hydroxide, we just need to multiply the concentration of potassium hydroxide with the volume of potassium hydroxide, which will give you 0.0106 moles. Since the molar ratio is 1 to 1 to 1, the moles of acetic acid is going to be 0.0106. Finally, moles divided by volume will give you the concentration, which is 1.6.